give probably a slightly different view. So I will mention how the testing environment works, but I'm going to sort of focus on why we've ended up with Lua as the way of writing that. So there's testing, but there's also other. The more here is the fact that L3 build does more than just testing, and we do other bits and pieces. Okay, so testing LaTeX. We want to test. We need tests. That's the first thing to say, and we want to test the programming, but we also want to test the typesetting that we get out of it. So testing programming means you can arrange to have simple yes/no tests. Testing typesetting means you need to look at the output that TeX creating. You want to test things without having to do any sort of special binaries. You want to be able to take what you've got in terms of your input and just convert it straight to your, to test it with no special things which could then mess up your testing. We need a testing system which can deal with the particular unique requirements of testing the LaTeX kernel, which means things like you have to build a format, you have to run your testing such that it's completely isolated from any installed TeX system, so you're definitely testing the files purely the files that have been used in the kernel distribution. And we wanted it to be, we want a testing system which has got minimal dependencies on other things, so essentially you want your scripting to be self-contained. The reason there is certainly historically the LaTeX team have wanted, effectively, you should be able to build the LaTeX format starting from just having some binaries that Carl has compiled, I guess, and basically nothing else at all, not even the plain text format. So the approach, which goes back a long way, well before us, goes back, I think, to when Frank had this conversation with Leslie, basically, more or less. Write some stuff to the log, include markers in the log that you can use to pick up which bits you're interested in and which bits you're not. Normalize the log such that it's not going to contain system-dependent data, and then compare it to some reference version that you've checked manually. And that core approach has been around for a very long time. So I've got here an example of the type of input we might do to do that. So this is one. So I've picked one from my SINTX v3 tests because I'll be talking about that tomorrow. So I'm going to look forward. So this is just some testing I've set up for that. So we have inputting some macros which are going to do the business end. This is just standard LaTeX. Key things, we've got a start. We've got some. So this is in X3, so it's got weird spacing going on. We've got some markers for skipping over some stuff we don't want to test, and then we have a series of tests. And you'll see this one is just very simple basic formatting of integers. So the point is we end up with just a file, a TeX file, which we can run and which will generate something. So those tests, these tests here, these particular tests are testing at the programming level, so they just produce token lists that you can compare. So this is what you get out. So this is our reference log file where you'll see we get nicely human readable what we've got, and we have, you can see here, we've got this. You might not show up all that well, unfortunately, on projector, but this is text normal because I've told it to show some macro content effectively. It would have L something something something, but we don't really care what that line is. So the normalization has turned that into just 3 dots. So we don't. If I change one line in my test, I don't have to change everything. So that's the basic idea. I say the core macros go back to the early 1990s, and I believe the very first way that this comparison was done was just set for the normalization.
You said that. I don't think it was set ever.
No, wait.
Probably AWK.
Okay, well, it's before my time, so there were various early approaches to doing that. But then certainly a Perl script was when I came in here with some make files which did things if you were on a Unix system, which when I joined the LaTeX team was a bit inconvenient because I'd got a PC so I couldn't run it. So then we stuck with Perl, and I wrote a whole load of bonkers Windows batch files which did more or less the same thing as the make file, except they were separate. And so the Perl script was the same. So the normalization bit was the same, but everything else was different. And the two inconveniences there were, first of all, they were different, and they had to, when we changed something, it got really, really complicated. And secondly, Windows doesn't come with Perl to start with, so we're back with the minimal dependencies this wasn't exactly ideal, and I don't understand Perl either, so that was a pain. And then, for releases, we had this set up using a system called cons, which I don't know if anyone else is familiar with cons, but it's essentially abandoned. So setting it up was quite interesting. It did sort of work, but it was a bit of a pain. So it got a bit messy, that I think it's fair to say. So what were the requirements? We wanted some setup where we could just use what you installed. So if you're developing LaTeX stuff, you've presumably got a TeX system installed. And that's a reasonable assumption as a starting point. And if you look at a modern TeX system, it's going to have various things built into it. So we want to use just what's built in. So we wanted to rewrite our test setup using just what was available and working across multiple engines. So the Perl script that we had before was very simple. It would do once it had been written with the idea that you'd be testing against eTeX basically, and that would be it. So you'd have one set of input, one output, and it would be the same irrespective of your engine, because it didn't really think there was more than one engine. We also want it to be cross-platform, so you've got, when you look at the log files, if you're on Windows, obviously the paths look different to if you're on Unix. We wanted a product, so if we were going to go to the effort of reworking this, so the testing environment for LaTeX itself has been around for a very long time, but it was really an internal tool which wasn't distributed by the team. So that means things like making it flexible enough that it can do things that we don't necessarily do or hadn't thought about, and also documenting it. And we wanted it to support a wider release workflow, and the reason there is, as I say, we had the sort of scripting for testing, and then you've got the scripting for doing releases, and you end up needing the same kind of things for a lot of that. So you're looking about moving files around, running tech runs, listing the contents of directories and things. So you end up needing more or less the same stuff. Okay, so that led us on. So we looked at what was available, and of course you look at your TeX system, and the scripting language you have is Lua, and Lua is very lightweight, but it's very powerful, provided you, apart from some of that system-dependent stuff, which I'll mention briefly. So what we've ended up with is a tool written in Lua, which can do all of those things, hopefully, for us and for other people. So it's called L3 build because it's from the LaTeX 3 team, and we've called all of the modern stuff L3 something, basically. And currently, this is the output of if you ask for some help at the moment. Most of that's automatically generated from the internal data structures now, so rather than, originally this was sort of, I just coded in a load of massive help block, but now if you look at the sources, this is all generated from the fact, well, this bit's automatic, this bit I still have to automate. I'm supposed to be making this. This is all of these options are stored in a table. These are currently just all hard-coded, so they need tidying up, but I haven't got round to that just yet. I've been busy with other things. So we can do various things. So we can do, the core idea, the checking. So we can use the Lua to do that normalization of our logs, and to deal with multiple engines, and to deal with the fact that Lua TeX just is completely different in the log in lots of places to everything else. It's a pain. You can do some cleaning up. You can typeset your documentation. You can install stuff. You can save your tests, which is important if you're going to check them. You probably at some stage need to save them. You can uninstall, which might seem a bit of a weird thing to do, but certainly for me, when I'm testing things, I want to quickly go, no, go back to the system, the release version. We can do unpack, which is a sort of very low-level thing. And we have all these options, some of which are probably going to disappear. That one's probably going to disappear at some point, because I know Ulrika's interested in PDF testing, and that's something that is kind of not really right at the moment. You might notice some slightly strange options, like you can shuffle the order of tests. This was one of Bruno's suggestions. On the grounds, if you have failing tests, if you keep rerunning them in the same order as you fix them, it takes longer than if you shuffle them, because if you shuffle them, it's asymptotic towards when we fix all the issues, because you test different ones. So it's a bonkers Bruno idea, which is what you'd expect if you know Bruno. So how does the configuration look for users? Well, this is where we get into the fact that Lua is a very nice user language, as we've already heard. It's very nice and simple. So from the user point of view, we've come up with these little build scripts, which essentially, yeah, so this is, again, I'm sticking with SI Unitext version 3. So you get a bundle and a module, which is just how you describe your package. So the reason we have two parties for the LaTeX 3 work, where we have a very large collection of different things, we have them bundled up, so you have several LaTeX packages in one, well, in a bigger container. That's possibly one of those things that I said is really I don't imagine anyone else will use that other than the team, but you never know. Someone else might want to bundle a load of things up. Simple configuration, so install files hopefully is pretty obvious. Packing a zip, so there's one thing currently that we need that isn't part of a TeX system or part of the operating system itself, and that's on Windows. Creating zip files is a bit of a pain. It has been suggested you can use PowerShell things to do that, but that's really tricky. So the one thing that needs an external tool is making zip files on Windows, where you can get InfoZip to do that for you. Typeset files says I've got a few. So the point is these are all non-standard things. So I changed this is basically the very non-standard things. I've got a little bit there to do what I've called tagging. So that's changing the version strings in files, which will depend on exactly how your files are set up. So for my ones, they look like that. I've actually changed that. I've actually realized that's a bit inefficient. I can change that. I only realized that yesterday, I think, so I haven't changed it in my slides. And then we go for all this script, and at the end, because we've fiddled around a bit with how we've set up, we used to insist you ran your little configuration scripts, and now we've changed it so you don't have to. So there's a little bit at the bottom which will work both ways. So hopefully that's all most people should ever need to configure the tool. What works well? The core idea of testing, that's been the design idea from day one. So if you look at that, so we have the normalization is the longest single part of the entire business, because normalizing out all of the differences between PDF Tech, ZTech, and LuaTech is fun, particularly if you're normalizing the differences between, as I say, LuaTech and everything else. So we have that bit's mind-bending because of the way it has to work. I really don't want to change that much more, but it works at the moment, I think. So it can test multiple engines, and we have a setup which will let you have different test files for different engines if you need them, but only if you need them and not if you don't. We've relatively recently added multiple configurations, so sometimes you simply have to have. So, for example, if you want to run your tests where you use load font spec and you tests where you don't, you might want the same tests from different setups, and so we've arranged that you can do that. It'll build PDFs, it'll make zips and make them for CTAN. It doesn't currently send them automatically to CTAN, but David is supposed to be working, or David has a version that will do that. I need to get him to merge that back in. And the basics of that idea of tagging sources works nicely. What doesn't work so well, there's still a bit of inflexibility in how you select tests, because that's currently it just runs all the tests you put in. I need to revamp PDF-based testing, because we sort of set that up. We were asked about it. I set some stuff up. Kind of works, but it's not quite right at the moment. So I need to go back and do that. Working on tagging files, yeah. So different people have different approaches to whether they think their version strings are part of their source files or should be something you don't commit to your sources, but you change when you build for release. So if you look at, for example, BibLaTeX, the version strings are never checked in there. They're only ever set when they run the make script that currently does that. And I've promised to sort out testing for BibLaTeX, so I need to sort out that, because you can't run the tests unless you put something real into the version strings, because they've got a filler in that's not a number. And so when you try to do a package loaded later test, it fails because it's not a number, so it goes wrong. So you have to fix that. So I need to look at that, but I haven't got around to it yet. There's other things people want me to. There's other various little niggles as well, but most of it works very well. yeah, a few people to thank. I'm going to keep my actual talk very short because I think I might show how the configuration works is the plan. Frank and David, I think, wrote most of the initial testing ideas. Is that right, broadly? Yeah, and they still there. This chap here, one of the things that we need in order to make all this work is to turn file specifications into Lua patterns, and I didn't come up with the code to do that. I nicked it off this chap here. And I simplified it a bit because he made it more complicated, and I thought, oh, this is too complicated. I'll just force people to use simple things. Will did various things. Yes, we had one monolithic file, and Will did all the work to turn it into lots of small files, which are much easier to maintain. Yes, I'm sure it was. Lots of Stack Overflow answers. The reason I've put many Stack Overflow answers is the one thing that Lua's basically platform neutral. So dealing with the platform specific things to copy files, to list files, etc. There's a module called LFS which does some of that, but then some of it you still have to kind of do by knowing the commands on different platforms. So a lot of that has come from the batch scripts I'd written before for Windows. So I took all the batch files, I pulled out the useful bits, and they're all little Windows-specific parts of the code, and then the Unix-specific parts of the code came from the make files we already had. And so most of that is done by just saying, right, what platform are we on? OK, right, then pick the line which makes sense depending on which platform we're on. And then Travis CI, because one of the reasons for wanting a reliable a viable test setup is to automate the testing, which I think has been very useful. And currently we're taking advantage of Travis CI to do that. Their documentation is quite good as well, and it works quite nicely. And I'll point to our GitHub repository. But beyond, that's really what I wanted to say there. The reason I've gone for my laptop rather than the main thing is in case anyone wants to go through any bits examples. I know that Ulrika had some questions. She's keen to put me on the spot about how things do or don't work. But really, to summarize, the point here is that it's not actually, the code we have now is actually much, I think, more maintainable than the setup we had before. And that's because, as I say, Lua works very nicely for this. It's very easy to write these kind of scripting things in. I could talk about other scripts I've knocked up for the team or for other things as well. But I just really wanted to say something Lua related. It's not as clever as, so I say, Mikko's talk was incredibly detailed about all sorts of things and the cleverness you can do using Lua Tech. But at the moment, the team's code hasn't really gone down that route other than Frank's stuff that he won't show people. He's not talking about Alice this here, are you? So no. So we won't get to see that. But I thought it would be interesting to say at least that we are using Lua more or less all the time, but not currently in the sort of the tech side, but just as a scripting language. So that's what I wanted to say, really.
Any questions?
Thanks for the interesting talk, Joseph. Do you think that L3 build will ever become useful outside of the LaTeX ecosystem?
I didn't talk about that. So one of the things I didn't put down there is you might ask why write our own tool rather than just sticking to sort of generic tools like Make. And the thing is, we've got, I guess, particular requirements of what we want, in the sense that you can, if you look at, so the idea in L3 build is we've got all these simple set of variables that control how things are done. Almost all of how things are done. And it's restrictive in a way because it means you have to stick to certain assumptions about what the kind of things you might be wanting to do. But at the same time, the idea is that applies to the vast majority of LaTeX packages. I think it's deliberately somewhat focused on our particular needs, is what I'd say. So it's probably not so useful if you're trying to do something else, other than you might load it and use some of the basic functionality, like the fact we've gone to the effort of working out how to do all the file copying and tree enumeration and things. But beyond that, probably not. I think it's kind of I'm not going to say deliberately limited, but it's deliberately focused on the needs of doing LaTeX package release. Does that seem fair to you?
Yeah, I guess I would struggle to figure out how I would extend it to,
Yeah.
let's say, checking some MATLAB code that I had to write.
Yeah, exactly. I mean, the checking is very much focused on tech runs.
But having said that, when I am writing engineering software and so on, I have a need to kind of bundle it up and do some typesetting and then zip it all together and make it distributable.
Yeah, I think maybe I think there maybe people might pick, you could probably take the stuff we've got and reuse it somewhere else rather than thinking the tool itself. Because I think most of the core functionality I think is more or less right, particularly since we've added the ability to traverse trees of files and copy subdirectories and things from within Lua. So that works quite nicely for things like Beamer.
We should ask the Lua team a question.
Oh, my laptop's gone off.
What kind of test suite do you guys have? If any?
I don't make mistakes.
I guess on the Lua side of things, yeah.
Yeah, we have a lot of tests. But the Lua, it's now like 20. Currently, Lua has like 25,000 lines of code. We have like 12,000 lines of test code.
Pretty good.
Yeah, and if you turn on all options, we have a cover of 99.6 or 99.7% of the code. So it's yeah, I think it's reasonably We follow that stuff of extreme programming too. That something does not exist if there is not a test for it. Usually, we try to, of course. The main problem, the limiting of our tests are memory. Sometimes, for instance, if you want to test up to overflow of integers, for instance, tables are limited to ints, and then you have to have a table with 2 billion entries. And so you need a machine with at least 64 gigabytes or maybe 32 gigabytes sometimes is enough. But my machine doesn't have that, so I cannot run those tests in my machine. But
We should try and type
Yeah.
a document.
yeah, but
Well, that's the PDF limit, I guess.
so there is some very, very strange corner cases that we are not test regularly, but usually they cover. And even then, there is still several bugs, but not many.
Okay, but I don't really have a question, but I made quite a number of tests in the past weeks with LWL, and it's a very fine system, but you need to get used to it. Yeah. Yeah, a lot of small problems you can run into it. At one time, I used a test file. My test file used another file than I thought it would use, but because of the normalization, I couldn't see it in the log. So I didn't know that it was using the wrong file, and it was quite fine. Getting the test on Travis can be difficult because on Travis you only get back again only a small part of the logs, and you don't know really why it fails. So you need to figure out tests to find out what way is this
Well,
thing.
so the way I deal with that is I have a virtual machine set up on here,
Yes,
which is
it's
exactly the same. This is exactly the same as the Travis setup, and then I can look at it locally.
Because it takes some time.
Yeah.
Travis, you put it up,
Yeah.
and then you wait 3 minutes, and then you get something
Yeah. Well, I
back,
mean,
and it failed, and then you start again. It's hard.
yeah. I mean, with the issue, I guess there, is you can't. If you want to have normalization, that's kind of the sort of the payoff. One of the this is why there's a business about needing to be able to run on an isolated system. That file dependencies are a potentially big. It's something I'm still meaning to look at. I keep meaning to. I was saying to the team earlier. Now we have an MD5 sum primitive in all the engines. I've been meaning to add something to MD5 all of the all of your sources and then list those out, so you can at least know that one of them's wrong, even if you can't know what's wrong with it immediately from that. But yeah, that's job for I don't know, maybe tonight.
And different setups. The LaTeX team has a certain way to organize its files.
Yeah.
And when you have something different, it's not always easy to figure out how to set the variables.
Yeah, well, we have I mean, we initially wrote the tool.
Better now. It was.
Yeah.
You can do a lot, but you have to run a number of tests until it really works.
Yeah, I mean, yes, that's true, but we've extended to some extent, because originally we just wrote it for the sort of approach the team uses, which is everything is in the flat directory, but that not everyone does. So, for example, I use it for Beamer now, and Beamer's not like that. And that's something I inherited from previous Beamer maintainers, and I'm not about to change all of that again, because that's quite a lot of work. No more? Okay.
Thank you very much.
Okay.